Okay, so I'm going to start with the Boyle's Law first. Okay, so if we have our combined gas law, P1V1 equals to over N1T1 is equals to P2V2 over N2T2. Boyle's law basically fixed the amount of gas in the chamber, and so the amount of gas did not change. He also did not change the temperature. He kept the temperature constant. So the temperature is constant. What that leaves you or simplifies your combined gas law into this equation, P1V1 equals to P2V2. Note that the variables here are only pressure and volume. So Boyle's law, you can easily remember, temperature is kept constant. Boil, from the word itself, boil, you usually associate that to temperature. Okay, and so his equation is now P1V1 equals to P2V2. So what is his experiment about? So this is his experiment. He has a movable chamber. I'm sorry, he has a chamber and it has a movable lid or a movable piston. The gap between the piston and the walls of the container is really, really small, and he assumed that the gas will not escape out. It's just small enough for the piston to move up and down. Okay, so he basically put weights on top of this lid, and these weights will basically cause pressure or hold pressure, force, pushing against your gas. Okay, so these are your pressure. It's force times area. All right, so he started with 1 kilograms of weights on top of the lid, okay, and then he observed the volume. So the volume now is at 1 liters. Then what he did is he increased the pressure and he observed what will happen to the volume of the cylinder. He noticed that when he increased the pressure by 2 kilos, which is twice the original pressure of 1 kilo grams of weight, the volume has decreased from 1 liter to half its original volume. So let's try to do mathematical calculations to figure if that is valid. P1V1 equals to P2V2. The pressure is twice the original pressure, so it's 2 times P1. You're asked to solve for V2. Okay, so if we rearrange this equation, you don't have to. It's just my preference that I rearrange the equation so that I'll come up with the answer already. But if you're not comfortable with rearranging the equation, you don't have to. You just plug the values in there and then rearrange your values, your equation. Okay, so solve for V2. P1, P2 is twice the amount of P1, so I just substitute that into the equation. Notice that the P1 cancels out, and what I'm left with is just the unit volume. So by increasing the pressure to a factor of 2, I have decreased my volume to a factor of 2. So it went by 1/2 the original volume. So there's an indirect relationship between pressure and volume. As pressure increases, the volume will decrease. It's indirect proportion. Okay. So if I triple the amount of the pressure, then guess what? The volume will be decreased by a factor of 3. It'll go 1/3 its original volume. So let's try to solve this equation, this problem using the Boyle's law. So we have here a cylinder equipped with a movable piston. It has an applied pressure of 4.0 atm. The volume is at 6.0 liters. You're asked to find the volume of the cylinder, V2, if the pressure has decreased down to 1 atm. Now, I don't have to solve this. I'm just doing an analysis, quick analysis. Notice that the pressure went down to from 4 to 1, so it went down by a factor of 4. That means to say, if there's an indirect relationship with the pressure, with the volume, volume will therefore increase by a factor of 4. Okay, I'm expecting that the number here is going to go up to 24 liters. Let's see if I am correct. So P1 V1 is equals to P2 V2. Solve for V2. Put V2 on one side of the equation and put the rest of the parameters on the other side. So P1 is given, that's 4.0 atm divided by the pressure. It went down to 1 atm. The volume is 6.0 liters. Notice that the units of pressure cancels out, and what you're left is just the unit of volume. So 4 times 6 will give you 24. So indeed, I am correct. The volume did went up by a factor of 4. So it went down by 4. So it went up by a factor of 4. Okay. What I also want to highlight here is that as long as the units of pressure is the same, the units will cancel out. And so if you're given a different unit, say torr, on one of the pressure, you have to convert it so that the units will be the same so that you can dimensionally cancel them out. Okay, that's one of the things here. It's not always easy all the time where you're given atmospheres all the time. So be very, very careful. Now, Boyle's law, I also explain why there are some really, some techniques in diving which is really counterintuitive. If you're asked, I don't know if you guys had gone this, but then if you're going to take a diving certificate, you have to undergo several classes. And those classes are somewhat physics heavy. It will ask you to study about buoyancy, and sometimes will ask you to study the Boyle's law. They always say that when you're trying to resurface up, you always have to exhale whenever you resurface. It's kind of counterintuitive because some people always like to keep some air in as reserve, and then they're going to surface up. And that's really a no-no when it comes to diving, and Boyle's law will explain why. Okay. So when you're on the surface, if this is you and you're floating on the surface, the pressure that you are going to be experiencing is pretty much the pressure from the surrounding air, which is the atmosphere, and that is 1 atm. As you go deeper and deeper, as you go dive down, for every 10 meters of depth that you have dived, you always will experience an additional 1 atmosphere of pressure, mainly because water is also you're now surrounded with water, and water is also exerting some pressure. So for every 10 meters of depth, you're always going to experience an additional 1 atmosphere. So when you are a diver and you're 20 meters down below sea level, then you will experience an additional 2 atm from the water. So 2 atm, so a total of 1, 2, and 3. Okay, 2 atm from water and 1 atm from the air, a total of 3 atm. Now, say for instance, this is a case, you hold your breath and then you resurface quickly. What will happen to your lungs? Okay, so we're going to explain that by using the Boyle's law. Okay, originally you're down here. The pressure is 3 atmospheres, and when you resurface, then the pressure is now 1 atmosphere. So it went down to 1 atm. So if you hold your breath so that you've expanded your lungs, so this volume 1 is pretty much the volume of your lungs, right? So what would now be the volume once you resurfaced? If we rearrange this equation, you're going to end up with the number 3 times the volume of the lungs. Okay, so the volume of the lungs will expand to 3 times as much. And that's really scary because if you've already held your breath or you hold your breath, you pretty much have air trapped in your lungs. As you resurface up, you have expanded that gas to 3 times as much beyond the capacity of your lungs. And so what would happen is that you're creating so much force into the capillaries of your lungs, and that will cause to some damage to your internal organs. And so they would always recommend to exhale or keep the amount of air inside your lungs as low as possible, so that if it do increase by 3 times, it's going to be tolerable. It's going to be within the limit or the capacity of your lungs.